Statistical distributions are used to model and predict the probability of a given event in a certain situation. Different distributions apply in different scenarios, and in S1 we're going to cover two of these, the binomial distribution and in this video the normal distribution. Now a data set is said to follow a normal distribution if the majority of the data values are centered around a mean, with gradually fewer moving towards the extremes. And as we will find later on, due to the central limit theorem, the normal distribution is fundamental to all of statistics. The standard model is a special normal distribution, denoted as Z, such that the mean is 0 and the standard deviation is 1. Now the reason why this is important is this particular curve has been extensively studied, such that we know the properties and the probabilities of all given values less than and greater than, etc. Now even though the majority or all normal distributions that we will encounter in statistics won't have this property, using clever transformations we can actually use our standard model to make predictions on any other model. We do this with the equation Z is equal to x minus mu over sigma. This effectively is just a transformation, turning a normal curve into the standard model. And in the examination we would have to write this down. Let's see an example of this. So in this question here, you can see it tells us that it's normally distributed and it's got a mean of 253 and a standard deviation of 5, and it says the probability that x is less than 250. Now the first thing we're going to have to do is we have to turn this into a standard model question. And we're going to do this by taking on Z is equal to x minus mu over sigma. X in this case is 250, our mean is 253 and our sigma is 5. And this results in giving us a value of Z is equal to minus 0.6. Once we've identified this Z value, we just go to our calculator and plug this in and we'll get the probability of 0.274. We'll see how to do this in a calculator a bit later on if you're unsure how to do this. Another type of question that arises quite a lot is where it gives you the probability of a normal distribution and it wants you to work out, for example, the values of x. Now in these questions you want to read it very carefully, so let's have a look at part B here. It says determine the value of x such that the probability of x is less than little x is equal to 0.98. Now it's really key to try and get your diagram right here, and as you can see this means that we've got some value such that 98% of the data lies less than this. Now what you do here is you use your calculator to work out the Z value that corresponds to that. Again, we're going to come onto the calculator work in a bit if you're unsure how to do this. In this question you're going to get Z is equal to 2.054. Now once you have your Z value, it's a simple case of using that formula again. Z is equal to x minus mu over sigma. So we get 2.054 is equal to x minus 421, which was the given mean, over 2.5, which is the given standard deviation. And therefore we get the value of x to be 426. So that means that 98% of the data would lie at less than 426. Part C in this question, although we won't do it here, is very similar. So have a go at that if you want to. Okay then, let's have a look at how to use our calculator for the normal distribution. So just like any others, we're going to go to Start, number 2 in the menu. And then on the main thing, we're going to end up with this. And we're looking for distribution, which is F5. And we're dealing with the normal distribution, so this is going to be F1. And we're presented with three options. We've got MPD, NCD, and inverse normal. Now MPD we're never going to use. The only two that we're interested in is NCD and inverse normal. Now let's have a look at a few questions and how this may help us. So we have a look at the first one. If we're trying to work out the probability that the Z is less than 0.5. Now this is an NCD question. At the top, you need to make sure your data says variable rather than list, so change that if not. Now we want to work out the probability that Z is less than 0.5, so our upper bound is 0.5. Now the lower, we don't have a lower here, so the way we get around this is we type negative and we just put a load of 9, so a really large negative number. The mu should be 0 and the sigma should be 1, and they should never change. And then from here you execute and you'll get the resultant probability, 0.6914. If we have a look at part B, find the probability that Z is greater than 1, so if I just press exit and come back, this time our lower bound is going to be 1. And the upper bound, well, we don't have an upper bound, so we just make it a very large number, put the 9s in, sigma and mu remain the same, and we end up with the answer 0.158. And then part C, this is where we're given a lower and an upper bound. So the lower bound is 0.3, the upper bound is a 2, and we end up with the probability 0.359. The final type of question I'm going to show you is the inverse normal. So this is, for example, if you're trying to find a probability that z is less than little z is equal to 0.2. So this is where you've got this graph here. So this 20% of the data lies less than this. Now the way you go with this is where you're going to go distribution normal, and this is where we use the inverse normal button. Now if you imagine this here, we've got tail, and it's going to be on the left hand side because it's left here. The area is 0.2 because that's our percentage. 20% is a decimal, is 0.2. And then all we do is execute, and this is telling us that minus 0.841, so our little z will be minus 0.841. Let's have a look at some sample mean questions. Whenever you come across a question that says sample mean involving a normal distribution, you're going to use a slightly different formula. It's going to be z is equal to x bar minus mu over sigma over root n. Now this sigma over root n is often referred to as the standard error. This is your new standard deviation, effectively. Now the reasons behind this is to do with the central limit theorem, but we're going to cover that in a different video. Let's have a look at some examples. So in this one we can see, it's on part 2, it says a random sample of 4 bags is selected. Calculate the probability that none of the 4 bags contain between that. Now it's key, in this question it does not mention mean. Even though it's not sample, it doesn't mention mean. So in this question we're still using z is equal to x minus mu over sigma. Specifically, we're going to be working out the probability that one of the bags doesn't contain between that values, and then we're going to raise it to the power of 4 based on our laws of probability. Now if we come down to part C, this is where it changes. Now it says a random sample of 6 bags is selected, and it says calculate the probability that the mean weight of the 6 bags. So now we're involving sample mean, and it's this question where we're going to use this new formula. Z is equal to x bar minus mu over sigma over root n. And it's really important that you understand the subtle difference between these two questions. One of them is just talking about a sample and them all having a certain property, so you raise it to a power, whereas the other one's talking about a sample, but it's the mean of a sample. And this is where we use our new formula. Let's have a look at a few more examples. So in this one here, we can see it says a box containing 16, given the probability that we regard as a random sample, determine the probability that all 16 balls have this property. So again, it's not talking about the mean, it's talking about the probability that all 16 have a certain property. So you work out the probability that one of them has it, and you're going to raise that to the power of 16. Whereas on part 2, now it's talking about the mean diameter of that sample. Here's sample mean, so this is where rather than raise to the power of 16, we're going to be using a new formula, z is equal to x bar minus mu over sigma. And we're going to have a look at one final one, because again, this is a really, really important thing to get your head around. On this one here, again, it says packs of 6, so this is talking about a sample, and in part I, it says volume of water in each of the 6 bottles, so all of them. They all have a certain property. There's no mention of mean, so we're going to find a probability that one of them has that property and raise it to the power of 6. Whereas in part 2, it's specifically mentioning the mean of that sample. So in this one, we're going to be using z is equal to x bar minus mu over sigma over root n. Right, let's have a look at some important points for the normal distribution. The first of which is your two values of z. You've got z is equal to x minus mu over sigma, or z is equal to x bar minus mu over sigma over root n. The latter, being in a formula bucket, is for when you're dealing with the sample mean, and the former is when it's not a sample mean. The second point is to remember the difference between when you've got a probability for a sample and you're going to raise it to a power, in this case to power 16, or when instead it's a sample mean question and you're going to be using z is equal to x bar minus mu over sigma root n. We made reference to this earlier in the video, so if you're unsure, just go back and watch that. Point 3 is the notation. Now this isn't as important as with the binomial distribution, but from time to time it can be presented in this way. So you need to remember that if it is distributed normally, then it's going to be given as mu and sigma squared, or the variance. So if you get data in this way, to work out the standard deviation, you have to square root the number that's on the right hand side of the bracket. Point 4 is the continuous data. remembering that normal distribution is continuous data, and what this means is the probability that is equal to any given value is always 0. It's so negligibly small that we count it as 0. And they like asking this. They like saying, write down a probability that x is equal to something, and the answer for a normal distribution is 0. And similarly, if you find out the probability that x is not equal to that value, well, it's going to be 1 or 100%. Now, point 5 is one that always catches students out. And this is the idea that it says explain why it's unlikely to be normally distributed, and they'll always give you some data before this. So in this case, we're told that the mean is 118 and the standard deviation is 65. And what we do is if we go down 2 standard deviations, we end up at minus 12. This means we've got a negative amount, and this means that there's a proportion of the graph or the curve that is going to be in a negative region. Now for a normal distribution, this isn't a problem. But in this question, we've got context. It's talking about volume of water. And the idea of having a negative volume of water does not make any sense. So because there's going to be part of a graph that doesn't make sense in context of the question, we say it's unlikely to be normally distributed. And I think the best way to go about answering this in an exam is a sketch like we've got on the right there. A simple sketch with a comment talking about something lying in a negative region will show the examiner that you understand exactly what is going on. Point 6 is remembering about the symmetries of a normal curve. So for example, if they tell you that 10% of the data lies less than 25 and 10% of the data is greater than 41 and you need to work out mu, well, you could work out two simultaneous equations and do it that way, but that's a lot more long-winded. Alternatively, you know that mu lies slap bang in the middle. So simply just work out the midpoint of 25 and 41. And the last point is using your equations to find other values, specifically mu and sigma. We're so used to questions where we're trying to find the value of x or the probability and so on and so forth, whereas quite often they'll give us the values and they'll tell us that z is equal to this, they'll tell us x is that and sigma is that, and they want us to plug it into z is equal to x minus mu over sigma, instead to work out what mu is or to work out what sigma is and so on. It's just a case of rearranging the equation to get those values.